This clip works through an example of calculating integrals, indefinite and definite ones, on the Wolfram Development Platform. So I prepared a file here, and let's say what we want to do is we want to calculate the indefinite integral of this function here, 2 times x to the 5 minus 3 times x to the 2 plus 2. So what we are after is this integral here. That's the funny integral sign and the dx, and the integrand is in here. So how to do that in Wolfram is fairly straightforward. We use the command integrate. So capital I, that's important, then in square parenthesis. First, we're having 2 inputs. First, our function. So I'm just replicating the function, and then comma x, and that is the variable with respect to which we want to integrate. So I'll press Shift Enter or evaluate cells. So I'll just have your cursor into that in that line, and then press Shift Enter, and you get the result. Now, of course, we know the indefinite integral is still a function, and here it is. Okay, this is the indefinite integral of this function. What this function does not have is a plus c and a constant of integration. It's just a convention of this language. So that is the first. Okay. Now, when you do want to calculate indefinite integrals, or later also definite integrals which involve exponential functions or log functions, it's very important that you understand how to write them properly. So let's use 2 examples here. Let's say you want to integrate the function 3 times the exponential of x. Okay, we could actually have a multiplication sign in here, but Wolfram actually does understand that the default operation is multiplication. So 13 times the exponential of x, exponential with capital E, little x, little p, and then in square brackets we have the variable, and we want to integrate with respect to x. So I have my cursor in here, Shift Enter, and perhaps not surprisingly, if you know the rules of integration, you get 13 times e to the x. That is a special due to the special characteristics of the exponential function. What about a log function? So let's say we want to integrate log of x. So 13 times log of x. Log function you have to write exactly like this, capital L, little o, little g, and then in square brackets the function of which you take a log, in this case just x. So Shift Enter, and here is our indefinite integral. And for those of you who remember the log rule of integration, this should look familiar. So what if you wanted to calculate a definite integral? So the only difference here is that you are now indicating that you have a lower and upper bound, and that lower upper bound meaning that you want to calculate the area underneath the function between these 2 points. So actually, before we do calculate this, down here I have a command, because when you calculate integrals, often nice and useful to visualize the function. Here we plot this function. Okay, let me plot this first. Okay, so this is the function, and what we want here is the size of the area between -1 and 2. Okay, this means subscript -1 and superscript 2. Okay, so we're having between somewhere here and here, we want to calculate the size of the area. That is what we call the definite integral. So how do you do that? We're using the same command. So integrate, then the function, then comma, the variable with respect to which we integrate, in curly brackets, and still in the same curly brackets, the lower bound and the upper bound. Right, so we do this, and the result is 9. So now, of course, please always do remember, if you practice your integration techniques, that you use this just to check your results, because clearly in an exam you will not have this available. But for your practice and revision work, if you want to go back to tutorial questions, you can use this to check your work, whether it's right or wrong. If it's wrong, well, then you have to figure out why it is wrong. Okay, that's all for today.